Welcome to Study Loop.
Here we are considering a hydrogen atom in the 2s state. So for a hydrogen atom in the 2s state, we want to know at what value of R is the probability P of R maximum, okay? And how does that compare to 4 times the Bohr's radius, which is the n equals 2 state for the Bohr's model. So the probability P is equal to 4 pi R squared times the wave function squared, where we replace the wave function psi with the wave function for the 2s state. So that's what is now written here. This is the wave function value in the 2s state. So we're going to go ahead and square that term. So the probability P is equal to 4 R squared over 8, a to the third, because the pi's cancel here. When we square this term, that square root goes away, the pi's cancel. Then this is multiplied by 2 minus R over a squared times e to the minus R over a. So the 2 cancels there with the squared term in the Euler's exponential. Okay, so now we know that this is maximum dPdr is equal to 0. So let's find PdR and then let it equal to 0, and then we can solve. So first thing, let's pull out the 1 over 8, a to the third, just a constant. Okay, and multiply it by, go ahead, and the first thing we come across is the R squared term, right? So we take the derivative with respect to that, and we can get, we're going to use product rules here and chain rules. We could also just go ahead and carry out the square here and then distribute the R squared term through. So actually, let's go ahead and do it that way. So let's first simplify this. So it's going to be by carrying out the square term to make it a little bit easier to do that derivative. So this is going to, carrying out this square term and then distributing R squared through, you have 1 over 8 to the third multiplied by, so if we carried out this square, this would be R squared over a squared minus 4R over a plus 4. So then carrying out the R term, that we have R to the 4 over a squared minus 4 over a plus 4R squared. And then this is applied by e to the minus R over a. Okay, so now it'll be a little easier to take the derivative with respect to R. So the first term is R to the 4th over a squared that we come across. So this becomes 4 R to the third minus 4R to the third over a. So this becomes 8 squared over a. Plus, now we have 4R squared, the derivative of that becomes 8R. And all of this gets multiplied by e to the R over a. And then we need to take the derivative of e to the minus R over a, now because that's the other term that has an R value in it. So this minus 1 over a, that's what we get from e to the minus R over a's derivative. So this is minus 1 times what we had previously, so this R to the 4th over a squared. So this entirety here, I'll do it in red. This whole thing here is going to, in the print, times e R. Okay, but this is all maximum when dPdR is equal to 0. So we can equal to 0. So all of this above is equal to 0. So the first thing we can do is multiply both sides by 1 over 8 to the third. So if we do that, then 1 over 8 to the third cancels. Then we can divide, because 0 times 1 over 8 to the third is still 0. Then we can divide both sides by e to the minus r over a, because that's a common. And the 0 divided by that is still going to be 0. So what we have here is we to the third a squared minus a r squared a plus r. You have minus 1 over a times, and let's look at those values. So you have 1 over a times r to the fourth over a squared. So this would be minus r to the fourth, the third, minus, then this would be minus a negative 4r to the third over a squared. So that'd be plus 4. Then minus 4r squared over a. Oh, I wrote 8 squared there. That should be 8, not 8 squared. Okay, and this is all equal to 0. So if you notice here, we can now start solving for r. So if we divide through by r, right, that's one thing we can do. If we divide through by r, that gets rid of this r term there. That squared term away. This r becomes squared. This to the fourth to the third. That was a squared, just becomes r. Okay. So now if we simplify and solve in terms of r, one of the values we get here r is equal to we have a multiply 3 minus square root. So this is a maximum value here. So therefore, the values of P of r is 0 for the radius r equals 2a and r equals infinity. Its maximum when r is equal to a times 3 minus square root of 5. So if you check this value, 3 minus root 5, right, it gives you 0.763, which is smaller than 4a. So we can say this is less than, which we were asked there too. So therefore, the probability for r equals 4a will be greater than the value that we just found of PR. So, and then for part B, so it says, at what value of r other than r equals 0 and r equals infinity is P of r equal to 0, so that the probability of finding the electron at that value is 0. So one of the values is when r is equal to 2a. So at 2a, the probability is 0. That's our solution.